Okay, so part 2 of your assignment is going to be converting a little bit from our particles that we did yesterday, which would be, again, particles can be ions, they can be formula units, they can be molecules, whatever those choose to be depending on what we have. Today we're using atoms. All right, so we're going to go from our atoms and we're going to convert that into grams. And so we have to do a couple steps. So one step that we have to do for this is we have to go to moles. And so atoms have to go through moles. We can't just skip all the way to molar mass because it's not equal. So we need to use Avogadro's number that we used yesterday, 6.02 times 10 to the 23rd. Again, make sure that's on your periodic table somewhere. Sorry, my writing's awful. Over 1 mole. 1 mole goes on the bottom. And then we want to look at our periodic table and find the molar mass, because that's what this really is. This is the molar mass again that we just got done doing. And we find out that uranium is 238. And so 238 grams, again, that's the average atomic mass. Multiply the top, again, using parentheses or your calculator doesn't work. You take 4.22 times 10 to the 15th, again, in parentheses, times by 238. Divide that, in parentheses, by 6.02 times 10 to the 23rd, and we get 1.668 times 10 to the negative 6. Again, we have to label it. That's grams of uranium. So let's do another one. All right, so here we go. We have atoms again. We need to go to grams. So we have to use Avogadro's number that we did yesterday right here. So it's just adding a step to our conversion factor. 0.622 times 10 to the 23rd over 1 mole of hydrogen. We've now canceled out the labels for atoms, because we have a mole here. Moles have to go here. So we put 1 mole of hydrogen. I know it seems redundant, but it will help out later on when we don't put moles anymore and we're actually using our balanced chemical equation to get those moles, so they're not going to be a 1-to-1 all the time. The molar mass would go right here. We look at our periodic table. Hydrogen is 1.008. We're just going to use 1 gram of hydrogen. So this one isn't so bad. We multiply the top, 1 times 8.45 times 10 to the 26, divided by the bottom. So we're just dividing by Avogadro's number here. And in this case, we are going to get 1403.6 grams of hydrogen, or you can write that into scientific notation of 1.4 times 10 to the 3rd grams of hydrogen. And so that's how we're going to do that mass to mole conversion. Again, on the extra problems, I'll do the other ones. But let's go, what if we're given grams here and we need to go to atoms? So here's where we're going to start. Our molar mass goes here. Again, we got to cancel out those labels of grams. So we're going to look at our periodic table. We're going to find out that mercury is going to be 201. It's 1 mole of mercury on the top. Again, labels cancel out. We have to go 1 mole down here of Hg. Labels cancel out. And then we're going to use Avogadro's number. I abbreviate by AV's number. 6.022 times 10 to the 23rd. We multiply the top, divide it by the bottom. So again, you take your 25.8 times your Avogadro's number using parentheses, divided by your molar mass, which we get from the periodic table again. It's 7.73 times 10 to the 22nd atoms of mercury. Again, everything's canceled out, so the only things you have left are atoms of Hg. So let's do another one. Okay, so we have 150 grams of argon. So we want to look at our periodic table. We got to put our molar mass of argon here. So we only have 1 atom of argon. It's going to be 40 grams of Ar over 1 mole. Grams now cancel out. 1 mole is going to go over Avogadro's number. Moles cancel out. So now we're going to take our 150 times our 6.022 times 10 to the 23rd, divided it by 40, and we're going to get 2.26 times 10 to the 24th atoms of argon. So basically we just added one more step from yesterday. And some of you are like, well, why don't we just put our molar mass on the bottom and just put Avogadro's number here? Why do we have to have these moles here? Really what it comes down to is those moles will be used in the next step or stoichiometry next chapter, and it's not going to be 1 anymore. It's going to be based on our balanced chemical equation. We're just doing simple atoms right now, so we're doing a baby step to that. So don't just stop doing the moles in there. You need to kind of write those out so you understand where the conversions, because when we don't do just a mole of mercury, but we're going from moles of mercury or grams of mercury to grams of argon, that step won't be hard anymore. And so that's why we leave those moles in there, because it really is a necessary step, because it's not always going to be 1. And so that's why we kind of leave it there. All right. So if you want more help, look at the extra problems. We're going to go through the rest of the problems that are on the practice sheet really quickly so that you have a chance to do that. All right. Talk to you later. Remember that assignment is already online, and you guys will be having a lab tomorrow. That lab takes 2 days, not because it's a super hard lab, but because there's a lot of math that goes with it. And basically you're doing 11.2 and yesterday's assignment 11.1 together in a lab. You're doing conversions. All right, talk to you later.